Hello and welcome to another exciting video brought to you by the Mathnasium. We're about to begin Unit 3 in Algebra 1, which talks about functions. Alright, so let's get started. Who would put an apple in a vending machine? That is going for the grandma's peanut butter cookies. Come on, you know me. You know me. Here we go. How does a vending machine work? Well, it's really simple. You punch in a code after paying too much money for your food. You're going to punch in a code and out comes the snack associated with that code. So one thing that's very important to know is every single code has exactly one snack that is going to pop out when you punch in that code. Say that one more time. Every single code that you punch in has exactly one snack that will be dispensed once that code is entered and it has been purchased. So, vending machine, in goes a code, out comes a snack. A beautiful thing, beautiful thing. A vending machine is a lot like a function in mathematics. We've been doing functions, like maybe something simple like y equals 2x plus 3. We've been doing this the whole time. In mathematics, they behave very similar to a vending machine, okay? So we will put in our code in case maybe we'll say x equals 1, and then you say y equals 2 times 1 plus 3. 2 times 1 is 2. 2 plus 3 is 5. Okay, so plug in x, we get the point 1, 5. We input a code, we get out our snack. Now, our snack and code are just regular old numbers in this case, so it's not too exciting. But it's the basic idea. This is our machine. This is our vending machine. And it has a way of taking the things we plug in and giving us back something else. So that's the whole idea. So we've been working with linear functions all of Unit 2, basically. So one thing I have to comment on this before we move on. Functions in mathematics are saying, why do I even need to know about functions if we were using them already? Well, functions and function notation, what we're going to be doing, this is a short little unit, is really, really important, especially when understanding computer programming. Because after all, someone had to program some sort of a computer here for the vending machine that, we have to plug this thing in, it recognizes the code, and then it takes that code and makes a decision. So something is back here making a decision. It's a computer. And you guys may not have a whole lot of experience computer programming right now, but I'm telling you, there is going to be a huge demand, there already is a huge demand for computer programmers currently all over the world. So it is something that I think we need to stress more in high schools. It's unfortunate that we don't because everything is electronic these days. But all of those decisions are made by functions in a computer program, and it's the same idea. In a computer program, stuff goes into a function, stuff comes out of the function and makes a decision. Same idea in mathematics, same idea in computer programming. Okay, so what does it look like? If it's a point, then it must be somehow related to a graph. So in blue, I'm going to say we call our codes that we use. We typically think of those as the things from our x-axis, or rather, let's say our x values. So we're talking specifically with math, just stuff like this. Okay, x values, these are also known as the inputs of our function. Or the domain. The domain is the set of all possible inputs. Okay, set of all possible inputs into our function. And then on the vertical axis, these are our y values. We think of these as like the snack. So this is like the code that goes into our function when we have a rule like 2x plus 3. And then out comes our outputs, and everything that gets hit by our function, every output that we get from our function is called the range. Okay? Perfect. Let's go ahead and keep on moving. Actually, first, I do want to mention that functions are a special type of what's called a relation. So I want you to imagine we have this subset of relations. It's like a shocked person. So here are functions, and functions belong to a set of mappings called relations. Okay, just a bunch of connections or ordered pairs. Not all relations are functions, but every function is a relation. So let's get into more detail. What's a relation? A relation is just a collection of ordered pairs. So some relations are functions, some are not. Today I'm going to teach you how to decide between those. And we can represent a relation in 4 different ways other than an equation if it's a function. So there are 4 ways to represent a relation that's not an equation. Okay, and the first way is written right in front of you. The first way is just in the form. Way number 1 is in the form of a set. Sets have curvy brackets and then they're comma-separated ordered pairs. So we can represent it as a set. That's just fine. We can represent it as a table. Tables are really easy to do. You just take the points and put them in for x and y in a column like so. So we would put 5, 5, negative 4, 4, and 4, 8. You can also represent them as a graph. Tables, points, graphs, nothing too new here. I'm going to be, well, let's see here. I'm going to go ahead and grab a graph from my thing to save me some time. I know you guys may not have these, but I did send some home, so hopefully you picked them up. Okay, graph bingo. Let's go ahead and go back to the full screen. All right, there's our graph. And so let's represent this relation as a graph. Well, we have 5, 5. We have negative 4, 4. And we have 4, 8. Beautiful, beautiful, beautiful. Yeah, look at that. So, go back to my selection tool here. Oh, copy. Let's delete that. Anyway, so we have a graph as way number 3, which none of these are too surprising to you. Probably set is new, table, graph, not new. And then the last one is new. Last one is called mapping. Okay, and what a mapping is it consists of 2 kind of like ovals, or whatever you want to call these shapes. And on the left side, we have our inputs, our codes for the vending machine, and on the right side, we have our snacks, or our outputs from the vending machine. And how a mapping is different than a table is, although they do not have to be alphabetical, I am going to write them alphabetical, or not alphabetical, in numerical order. I'm going to write them in numerical order. So typically you write like negative 4, 4, 5 for our inputs. Take these, and I could have written the table in that order too. It wouldn't have made a big difference, but I would have shuffled the order of the y's then. And then 4, 5, and 8. Oops, I'm going to undo that and make sure those are red. I'm going to be consistent here. Let's undo that. Four, 5, and 8 in our output. Okay, so with a mapping, only going to write, the reason it's different than a table, right? You're going to draw arrows. So we'll say, negative 4 goes to 4. Okay, 4 goes to 8. And 5 goes to 5. So that's what this mapping looks like. Okay. The reason a mapping is different than a table is a mapping, you only write each, I will say the numbers in each oval once. So in a table, if there were 2 points, let's say we had the point 5, 8 or 5, 9, you would not need to write 5 twice in the inputs. You just write it once and then add a new arrow. So basically, each number will only appear once in each oval if a number is duplicated. That's the main difference. And you'll see an example of that momentarily. So here we have our mapping, our graph, table, and our set. Perfect. Let's see a little bit better of an example. So let's write the ordered pairs as a mapping, and you'll see, this should go quickly, how many different inputs are there going to be? Take a second to think about that. Okay, there are only 3, and in numerical order, 1, 3, 6. Okay, in our outputs, how many different outputs will there be? Well, 7, 2, 2, 8, 2, 7, and 8 are our outputs. And now let's take a look at the arrow. So there's going to be an arrow, even though there's 4 points, there's 3 inputs and there are 3 outputs, but there are going to be 4 arrows. So there's an arrow for each point. So 3, 7, 3 maps to 7, 1 maps to 2, 6 maps to 2, and 3 maps to 8. So it's possible in a mapping or a relation to have arrows, 2 arrows headed to one number. It is possible in a mapping or a relation for 2 arrows to be coming from one of the inputs. Now typically in a function or a relation, there are an infinite number of things that are inputs and an infinite number of things that are outputs. So we're trying to keep it simple. We're kind of oversimplifying what we're writing here, but that's okay. Okay, so then what's a function? I haven't told you what a function is yet. I told you it was like a vending machine. I told you what a relation was. And I told you that a function, all functions are relations. But that's just a collection of ordered pairs. Great, Mr. Slagle, that's not very helpful. What's a function? A function is a relation where each input has exactly one output. Each input has exactly one output. So what I'm going to do here is I'm going to draw some mappings. This is our domain and our range, inputs and outputs. Okay, I'm just going to use dots instead of numbers because the numbers really don't matter. It's really the arrows that matter, determining whether or not it's a function. And then I'll do another one over here. Okay, these 2 mappings are functions. Okay, every input has to have exactly one output. This is okay. Every input has exactly one output. Notice the arrows are one directional. And here, this is also okay. Every input has exactly one output. That is, every input has a place to go. And in terms of a vending machine, in terms of a vending machine, this would be like every code, every code has a specific tray in the vending machine associated with it. This would be, there are maybe 2 codes that will kick out one tray. But that's still a function, that's still okay. It's still very easy for you to plug something in and get something out. You'd be able to control what's happening. Okay, let's keep moving. So what are some examples of, what does it look like if something fails to be a function from a mapping perspective? From a mapping perspective, you're going to see your oval here, here's our domain, here is our range, and then we're going to put, let's say, this would fail to be a function. So we have 3 dots in the domain, 3 dots in the range, or in our inputs and our outputs. This is not a function, and so it's this input that's the problem. This is our issue. This is what is preventing this from being a function, because this input has more than one output. Okay, if you're thinking about, so let's take a look back at this one really fast. All right, if this, we can plot these points, right? We can see, is this a function? Okay, the answer is no, but it is because of, this 3. This 3 prevents this from being a function. The input 3 has more than one output, 7 and 8, so this relation is not a function. So it also turns out that if we were to graph this, if 3 is the issue, some wise guy was like, if 3 is the issue here, 1, 2, 3, we have the point 3, 7, 8, and 3, 8, and they were like, oh, hey, look at that. So if two things have the same x value, if 2 points have the same x value, they end up kind of stacked on top of each other. You know what would be a great way to check to see if a relation is a function? If it's possible to draw a vertical line. So what I'm going to do right now is I'm going to really quickly, I'm going to throw on some functions really fast. And as I'm drawing them, I want you to think whether or not these are functions. Okay, let's do that one first, and then let's do this baby, and then right here, and right here. Okay, so the vertical line test is what I was just talking about. If you're looking at a mapping and you see that one point, has 2 arrows coming from it, and that means there's 2 points with the same x value, or at least 2 points with the same x value. And so we can look at that on a graph, and those 2 points will form a vertical line. So all you have to do to check to see if something is a function is you draw a line, and if you can make that line travel through 2 points on our function, okay, it's no longer a function. So that means this one, even though it's just points, is not a function because we can do that. So I'm going to write here in red, this fails the vertical line test. So this is not a function. Okay, it is the x value, x equals 1 is what is preventing this relation from being a function. How about over here? And I'm actually going to drag this. Like that, perfect. Okay, so right here, if we go right there, it looks like it's crossing 1 point. But I said if you can draw a single vertical line that hits at least 2 points of the relation, it's not a function. Okay, so this, they're basically at x equals 4, it looks like it crosses at 1 point. But anything less than 4, it's going to be crossing at 2. So this relation also fails the vertical line test. So this is not a function. So your answer on your assignment is not fail or pass. You're saying this is not a function, and the reason why is you give an example. So you just pick one. You can say like the x value is 0. So x equals 0 has more than one output. So this relation is not a function. Now let's take a look at this one down here. Can you draw is it possible to draw a vertical line, the arrows, this part doesn't count, that travels through more than 1 point? Okay, it gets pretty close right there, but it doesn't look like you actually get fully vertical. So this line, there is no vertical line that we can see on our graph that will cross in 2 sections. So that means, based on our definition, this passes the vertical line test. So this is a function. Okay, it's a function because it passes the vertical line test, or you could also say every input has exactly one output. Each input has exactly one output. So how about right here? Is this a function? It's very similar to the one we just do. Oh, no, we got a problem. Right there you can see that we've got 3 spots that cause an issue. Right here, right here, right here, and there are several different x values that cause a problem there. So immediately we can say, hey, this doesn't work. This fails the vertical line test. And it's really any x value, it looks like between like 1 1/4 and 2 are going to cause problems. So this fails the vertical line test. Okay, so that's basically it. So if I give you a set of points, go through and look. You can, I asked you on the assignment, like, turn this into a mapping, turn this into a table, turn this into a graph. How do you know whether or not it's a function? You have to decide this is a function, this isn't a function, and why. So the way that you can say it passes is because each input has exactly one output, or you can say it passes the vertical line test. The way you say it's not a function is you say this is not a function because the input, and then pick one, it looks like this input has more than one output. That's basically it. So thanks for watching. Assignments in Google Classroom. Hope you liked the video. See you next time.